Alright, today we're talking about exponents. So you all have a little book made up with 4 pieces of paper folded in half, stapled down the middle. So on the front, we just put our cover, so you can put whatever you want on there. I wrote Miss Featherman's book of exponent rules because that's what we're going to be putting in here. You can add some designs or some colors or however you want to make it look. So once you have the front cover done, you can pause this, work on it, and then move on to the next thing. Now when we go to a page, we're actually gonna, when you would open up to the first page, so we're gonna skip this because this is the back of our title page. So we don't want to write on the back of the title page because sometimes the markers will go through it. So we're going to go to the next page. Now on the next page, we are going to be talking about the parts of a power. So this is the parts of a power. So with the parts of a power, so we have 3 things. So our power is going to be something like 5 to the 3rd power. So this entire thing is a power. So it's a power. And what that means is we take the base. Well, the base is our whole number right there. So that's our base. That's the number that we're multiplying. It's how many times we do it. So we take that base and the exponent, which is the 3, this is our exponent. It tells us how many times we take that base. Well, so we take the base, which is 5, and we do it 3 times. So it's 5 times 5 times 5. So it's 5 to the 3rd power, which is why we get a power. And then we have our base is 5, the exponent is 3, so it's 5 times 5 times 5 times 5, which equals 125. So that's our parts of a power. We have the power, the base, the exponent. So the exponent, alright, so we said the exponent tells us, how many times the base is multiplied. So the exponent tells us how many times the base is multiplied. So that's our exponent. It tells us how many times the base is multiplied. So one of the other things is, very common mistake, if you just look at like the number 4. Well, there's no exponent. Well, what this actually means is this is actually 4 to the 1st power. It's 4 to the 1st power. So if there is a constant or just a variable, or so you could have like x, which is also x to the 1st power. So, or a variable. So if you have a constant or you have a variable that doesn't have an exponent, so that does not have an exponent. So if it doesn't have the exponent, alright, the exponent is automatically 1. Alright, so the exponent becomes 1. So if we don't have anything, it's always 1. So we had the examples up there. I mean, you could have a number where you could have like 2x y to the 3rd power. Well, we would know that this is actually 2 to the 1st, x to the 1st, y to the 3rd power. So they actually have those 1s there. Now, we're going to get into a couple of these rules here. So one of the rules, we have a power to a power. So if we're looking at one of the main rules that we're going to get into that you've talked about last year, so a power to a power. So power to a power. Okay, so a power raised to a power, well, so let's say we have like x to the 4th to the 3rd power. Well, x to the 4th to the 3rd power actually means x to the 4 times 3, which will give me x to the 12th. So what we have to think here is when we have a power. So when we have a power, so it's raised to a power, we actually multiply these numbers. So we're actually multiply. So we go one step down. So if it's a power, we actually multiply these numbers. Okay? So if it's raised to a power, we multiply. Well, if we think about, well, what if we're multiplying two numbers? So what if I have like x to the 4th times x to the 3rd? So now I'm multiplying. So we go from power to multiply. Well, below multiplying is adding. So what I actually have to do with these two numbers is this is going to be x to the 4th plus x to the 3rd, which gives me x to the 7th. So if we can remember the p to m to a, power to multiply to add, well, if it's raised to a power, we multiply. But if we're multiplying, we essentially are just adding. So we add these numbers. So that's a little thing that you can, a lot of people struggle with, what to do. Well, if it's a power to a power, we want to multiply the two numbers, and if we're multiplying, then we want to add them. Now, the other key thing that you have to remember is that you can only use exponents rules when you have like bases. So this is a key thing to remember. Alright, so we can only use exponent rules when we have like bases. So if we have like bases, we can use our exponent rules. And now here we looked at dividing or multiplying. Now if we're dividing powers with like bases, alright, the division bar, we just think of it as a big subtraction sign. So when dividing powers with like bases, so when we're dividing powers with our like bases, think of the division bar as a subtraction sign. So if we have like a to the 10th divided by a to the 4th, well, this is going to be a to the 10 minus 4, which is a to the 6th. So that's about when we divide, but once again, we have to have like bases. Now we're going to flip it over to the next page. We're going to skip that one and go to the following page so that, once again, we're not writing on the back. And then the last thing we have to talk about is negative exponents. Alright, so a negative exponent. So negative exponent. Now this is where most people get confused. Alright, so if we think about this, so if you have a negative exponent, so to turn a negative exponent, so if we want to turn our negative exponent into a positive one, into a positive exponent, alright, what we have to do is you just have to switch the line. Alright, so we have to switch the line, or cross the line, not switch. We have to cross the line, we'll say cross. So we have to cross the line. Cross the line. And what I mean by that is, well, let's say we have like x to the negative 4th and y to the negative 6. Well, I take this, I cross the line, it comes down here, x to the 4th, this is negative, that crosses the line, now it comes to the top, y to the 6th. Or if I give you another example, like 2a to the negative third and b to the fourth. Well, this is 2 to the first power because it's all by itself. Negative exponent crosses the line. B to the fourth is positive, so we don't do anything, so we're left with 2. The a to the third crossed the line, and a b to the fourth stayed down there. And that's how we get our answer. So if we think about just crossing that line. And then the last thing, anything raised to a power of 0. So anything raised to the power of 0. So anything raised to the power of 0 is equal to 1. So it doesn't matter if it's a letter, a variable, a number, anything raised to the power of 0 is equal to 1. So if you have like 6 to the power of 0, that's 1. X to the power of 0, that's 1. 2abc to the power of 0, that's 1. So anything that's raised to that power of 0 is simply 1. So that is what we are going to start getting into with our laws of exponents.